In this video, I'm going to explain to you about geometrical isomerism, also known as cis-trans isomerism, through examples. Example number 1, we have 2-butene. These two are geometrical isomers of 2-butene. The question is, which one is a cis isomer and which one is a trans isomer? A cis isomer is an isomer in which the similar groups or atoms lie on the same side of the double bond, whereas a trans isomer is an isomer in which the similar groups or atoms lie on the opposite sides of the double bond. So, using that, clearly in the first one we see that the similar groups lie on the same side of the double bond. So hence this one is a cis 2-butene. Whereas here we see that the similar groups lie on the opposite sides of the double bond. So this one is a trans 2-butene. Okay, now we come to the second example. See, we have 3-hexene. Now we see that the similar groups lie on the same side of the double bond. So this one is a cis 3-hexene. Whereas here we see that the similar groups lie opposite to each other. So this one is a trans 3-hexene. Okay. Now we come to this one, butene dioic acid. Now we see that similar groups lie opposite to each other, okay, on the double bond. I mean lie on the opposite side of the double bond. So this one is a what? A trans butene dioic acid. Okay, it is also known as fumaric acid. What about this one? Similar groups lie on the same sides of the double bond. So this one is a cis butene dioic acid, also known as malic acid. Okay, now we come to this one, propene. See, what about propene? Will it have does it have geometrical isomers? Does it show a geometrical isomerism? No. Why? Because, see, this is a double bonded carbon atom, right? We have a double bond here. Now we see that to this carbon atom, what happened? There are two atoms, similar atoms, hydrogen, which are bonded to this. So because of that, it does not show a geometrical isomerism. So you have to know that not all alkenes show geometrical isomerism. Only those alkenes in which the double bonded carbon atom is attached to two different atoms or groups, only those will show geometrical isomerism. But like in this case, we see that this double bonded carbon atom is attached to two similar groups, hence it does not show geometrical isomerism. Now we come to the stability. What do you think about the stability? Which one is more stable, whether the cis 2-butene or the trans 2-butene? Okay, so in that case, it is the trans 2-butene. Why? See, why is the trans 2-butene more stable than the cis 2-butene? Because what happened? Because we see that in the trans 2-butene, similar groups lie on the opposite sides of the double bond, right? Because of that, there is no steric hindrance. That's why it is more stable. Whereas in this case, we see that similar groups lie on the same sides of the double bond. That's why a steric hindrance is there. Because of that, it is less stable. Or in other words, we can say that in the trans-2-butene, since the similar groups lie opposite to each other, we can say that they are far apart. Hence, there is no steric hindrance. That's why it is more stable than the cis-2-butene. In the same way, this one is more stable. The trans is more stable than the cis-3-hexene. Like that, okay? So this is all about a geometrical isomerism.